Hi everyone, Assalamu alaikum. There's another question here, exam question on circle theorems. So let's get it started. We've got a circle with center O. The question says A, B, C, and D are points on the circumference of a circle with center O. FDE is a tangent to the circle. Show that y minus x equals 90, and you must give a reason for each stage of your working. Okay, so a few people were requesting questions on circle theorems, so I have a very specific way of solving these kind of questions. I look at the diagram first, and I try and find out whatever information I can have about this circle or from the diagram. So let's start. I'm going to highlight this. So O is the center of the circle. The line OD is a radius. Okay. FDE is a tangent that is mentioned. The quadrilateral ABCD is a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral where all of four of its vertices touch the circumference. BD is a chord. It doesn't go through the center, so it is not the diameter. And all four sides, AD, CD, BC, and BA are chords as well. Alright. Now there's a few circle theorems that you can use over here. I'm going to start off by finding out some angles. So let's get started. I'm going to mark this angle over here. Now this angle, which is angle FDB, is equal to 90 minus x. And the reason for that is the radius, this is a circle theorem, and tangent meet at 90 degrees. I'm going to try and get this to fit in. So let's show this on the diagram. That's your radius, that's your tangent. This angle here is 90, and the whole angle there is 90. So I'm going to get rid of that. Okay, so the red angle, since these two make 90 degrees, the red angle has to be 90 minus x. Okay, now angle FDB, since we are with angle FDB, we'll stick with angle FDB, is equal to angle DCB that is also, let me write this down. This angle here is 90 minus x. And this one will also be 90 minus x. Okay, we were writing in green, so let me stick with green. And the reason for this is the angle between a tangent and a chord is equal to the angle alternate segment. Okay, now this is the hardest circle theorem for a lot of people to understand. So I'm going to spend some time explaining this. So you see this angle over here. Ooh, let me stick to red. I'm going to try and shade this angle here. Not eraser, I want that. Where is it? Okay. This angle here. Alright. It's between the tangent and this chord. Okay. And this takes place in sort of this segment here. Okay. So any angle, let's switch to the pen. I'll try and do it in blue. Which starts at one end of the chord, touches the circumference, and goes back to the other end of the chord, will be the same as the angle between the tangent and the chord. Okay, so it has to start from one end of the chord, touch the circumference, and go back to the same end of the chord. Okay, and it will be in the other segment. So it'll be in, let's just shade it yellow, in this part of the circle. Okay, not the green part. Right, so my diagram, I'm gonna just get rid of that extra drawing on there. That was just to make some sense of what was happening here. Okay, so we know that now we've got two angles which are 90 minus x. Also, we also know, let me just reduce the size of the pen. Okay, angle BAD, ooh, this one's in blue now. Angle BAD, bad, plus angle BCD is equal to 180 degrees. Well, I'm going to leave some space and write down the reason. No, I'm going to write down the reason and then I'll continue with this. Okay, the reason for this is opposite angles in a cyclic quadrilateral. Some people like calling it cyclic, I like calling it cyclic. Can I fit it in? Nope. Quadrilateral. Add up to 180 degrees. So angle y and angle 90 minus x, that one over there, those two add up to 180 degrees. Similarly, yep, this angle and this angle will add up to 180 degrees as well. So those are opposite angles of a cyclic quadrilateral. Now if I go back to the question now, angle BAD, or bad, was y degrees. So I'm going to replace bad with y. Ooh, it's yellow now. I didn't expect that. And angle BCD, which is this one, is 90 minus x. So plus 90 minus x is equal to 180 degrees. So I subtract 90 from both sides. I'm left with y minus x is equal to 90 degrees. Now I've show that I've done part A, and I've given a reason for every stage of my work. And now let's do part B quickly. Right, Dylan was asked to give some possible values of x and y, and he said y could be 200 and x could be 110, because 200 and 200 minus 110 is equal to 90 degrees. Is Dylan correct? Well, and you must give a reason for the answer. Now, in blue, we've just gone over the reason. Opposite angles in a cyclic quadrilateral add up to 180 degrees. So 90 minus x and y degrees have to add up to 180 degrees. So how could y be greater than 180 when 90 minus x and y, both of them, have to be adding up to 180 degrees? You cannot have negative angles, can we? So I would say Dylan is wrong, since opposite angles. Let's do this one in blue over here. Where can I fit this? Can I fit this in here? Right, let me see if I can fit it in the lines. Dylan is wrong, since opposite angles in a cyclic quadrilateral one second, just move this out of the way here. I hope this is visible clearly. And so y cannot be greater than 200. Sorry, cannot be greater than 180. Let me explain that answer. Okay, so what I've said is this angle y, 90 minus x, are opposite angle of a cyclic quadrilateral, and they add up to 180 degrees. So the question asks if Dylan was correct. So Dylan is wrong, since opposite angles, I should put a comma there, since opposite angles in a cyclic quadrilateral add up to 180 degrees, and so y alone cannot be greater than 180 degrees, because these two need to add up to make 180. How can y be 200 degrees on its own? Okay, and that's the point I'm trying to make. Okay, hopefully this helps, and I'll try and upload some more videos on circle theorems. Hopefully download this pack. I've left the link in the description. Try some questions yourself as well, and hopefully this will help in solving questions in the exam. There's not much time left, so all the best with your preparation. Keep working hard, and thank you for watching.